Hello everyone. Till date, whatever videos I have created, I spoke about a common data store wherein all the queries are handled using the same data. So in that case, if either you are using my chatbot or I'm using my chatbot, we will get exactly the similar response for the same type of questions, which is perfectly all right. But what about the scenarios wherein we don't want to mix up all the data? I am expecting response which is very particular to me, and you are expecting response which is very particular to you or your scenario. So let's see how we can handle that. So in today's video, I'm going to talk about how can you segregate the data based on your business use case. So let's have a quick look at why do we need such kind of segregation. So there could be definitely many more scenarios or many more reasons to segregate your data, but the key ones which I can think of are these three. So the first one is data specific to the user. And if you will think about finance related chatbot or any investment related chatbot, so in that case a particular user will have its own data. Whatever the stocks I have bought perhaps not be applicable to you. So in that case every user will have its own data, and we don't want to club all these data in a single data store. So in that case we need a segregation, some kind of a divide between the data which are different for different kind of users. Another use case could be, let's say you are having a chatbot, or you created a chatbot which is going to target just one sector. So although your chatbot is going to handle lot many things, but we want to just filter out based on the user type or the sector. So let me give you an example. Let's say you have created a chatbot which gives you news. Now news could be either related to politics, games, entertainment, or any other thing, but as a user I'm interested only in entertainment. So definitely whenever I'm asking what's the news today or what are the headlines, I'm not expecting any news which is related to politics. So it means my particular sector here is my choice, which is entertainment. Similarly, coming on to the geography part, so if I will take the same news chatbot, in that case the people sitting in Europe may have different kind of headlines, and the people sitting in let's say Africa may have different kinds. So whenever they are watching the news or asking for news related stuff, the first priority would be their local news. So in that case we just want to geographically divide or segregate our data. So these are the high level use cases, and the one which I'm going to discuss today is about a particular sector. So I'm going to take a use case wherein we have two different things, hunger and the poverty. So whenever I want to ask questions related to hunger, I want a response only from that hunger related data. And when I am asking question from the poverty, I just want the response to be from the poverty related data. Doesn't matter how much data is common between them or how much different both of these data sets are. So let's have a quick look at this, how we can implement this using OpenAI. And in this particular scenario, I will be using Pinecone. Now, one more question you can ask is, if it is only about the segregation, why can't we create indexes based on user's choice or the segment? So one user, one index, another user, another index. So definitely that is a very good idea. But there are people who doesn't want to deal with so many indexes, and there could be many more reasons, like maybe they are charged based on number of indexes and how much data they are pushing into each index, or they could have their own constraints. So this particular scenario is applicable to those who wants to create just a single index for all the data they are having and want to just segregate that particular data inside that index. So let's have a quick look at this. So I'm using Pinecone and OpenAI. So I have already grabbed my keys for both Pinecone and OpenAI and set it in a variable. Then I'm importing these packages. So one is for Pinecone, another one is for OpenAI related stuff. Then what you need to do is you need to initialize the Pinecone. So for initializing the Pinecone, we need a key and the environment, which you can definitely grab it from the Pinecone client. Then you need to define the index. So what is the name of your index which you are going to query? So in my case, I'm taking demo index, and I'm saying that if by any chance, if this index doesn't present in given Pinecone database, then please go ahead and create it. So this is my index name, this is my dimension, and this is my metric. So these are the three things which can create index for you with this given name. So we have initialized our database, we have initialized or created the index. Next thing is we need to associate this index with the Pinecone. So this is a statement which is doing here, and once we have that initialized or connection between the Pinecone and the index is done, we are good to go with our vector store creation. So for vector store creation, you need to pass an index name, OpenAI key, and the field on which you want to query all these things. So in my case, it is text field, so I just added text over here. The next thing is pushing data into this vector store. So you can push data, there are many ways you can push it, but in order to keep this particular video simple, I'm just adding few lines of text to my vector store. So this is how I can add it. So this is one particular text and this is another text. And if you will look at this text, it is exactly same except few lines. So the first one is whenever user is asking question about poverty, and the second hunger, and the second one is related to poverty. And the main key thing which is segregating this is the namespace. So namespace is the major fundamental thing here which is going to segregate your data. So whatever data you are pushing under the hunger namespace will stick to the hunger, and whatever the data you are pushing under the poverty namespace will stick to the poverty. So this is how you can segregate your data before querying it. So now vector store is having two different segments in it, and both are separated by different namespaces. Let's execute this cell and move ahead. So in my case, I'm just taking a small or the few lines of text, but in your case there could be files. So this is how you can handle it. You can just read the file, split it using the character splitter, and generate the number of documents after those splits. So once you have these documents ready, you can push in using, I think, upsert function. So inside that upsert function, you can pass in each of these individual documents directly. So that is one way of doing. So I'm not going to execute it because in my case, it's pretty straightforward. Next thing is, now we have our vector store thing. We need to set up our OpenAI environment. So I'm going to execute few of these imports here. Then I'm setting the template. So in my template, I'm saying answer the questions based on the following context. And this is my context and this is my question. So here we are not doing anything fancy. It's this way we used to do when we are making a call to OpenAI. And here is the important thing, retriever. So here retriever would be my vector score, and this vector store consists of all the namespaces which are going to participate in this particular chatbot. So let's execute this as well. Okay, now we are going to configure fields for a retriever. So this is again different part which you have not done earlier. We never defined a retriever like this, but in this case we want to segregate the data. So what we are going to do here is, in this configuration field, you need to define where are you or how you are going to define your search criteria. Then this is the search argument and the description if you want to provide here. So once your configurable retriever is ready, you can just pass in the prompt, model, and the structure output. So str output parser is going to parse the LLM result in the string. So let's execute this as well. And before moving forward, I can quickly show you the index. So this is my index in the Pinecone, and here you can see at the bottom, I'm having hunger and the poverty. These are the two namespaces which I have created. So for poverty, this is my text. I can hover over it and you can just read the last line. It is very much related to poverty. Okay, so what this text is saying is what is hunger and whether hunger is related to poverty or not. So as per the poverty namespace, it is saying that it is very much related to poverty. Whereas if I will go to my hunger namespace and just query it, here the text is opposite. So if you will again read the last line, it is saying that hunger is very much related to poverty. So it means hunger is related to poverty, and in another one I am saying no, it is not related. So this is what we are going to query. And the reason why I took simple text is so that you can visualize whether things are really picked from the hunger namespace. So my question is hunger related to poverty? Now in one I am saying no, it is not. In another namespace I am saying yes, it is related. So let's quickly check it out. I am going to invoke this chain and here it is saying, as per the hunger namespace, yes, it is related to poverty. It's time to quickly verify it. So as per the hunger, it is saying, last line is saying it is very much related to poverty. Let me quickly shuffle this and ask the same question with my another data set which is related to poverty, and this time it should say no, it is not related to poverty. And the reason why it is giving is because in poverty, if you will read the last line, it is saying it is very much related to poverty. So this is how you can segregate your data based on the namespaces. And while querying, you can define this, whether it is whether this question should be responded from which namespace or from the entire data store. So this was the overall idea how you can segregate your data. I hope you will be able to utilize this concept in your use cases, and do let me know in comments where and how you are using this particular feature. Thanks for watching.